Today we would like to discuss few named photoreactions, and in these series, the first named reaction is the photo-Fries rearrangement, in which the aryl ester or aryl esters and aromatic compounds are having general formula as given over here, where X could be oxygen or nitrogen. When we have system like this under photolytic condition, it undergoes photophrase rearrangement involving alpha bond cleavage. So there is a cleavage of this alpha bond, and it to give a acyl radical or phenoxy radical if X is oxygen, and then this rearranges to give two products, that is orthoacyl phenol or para-acyl phenol, or if it is X is equal to N, then it lead to the formation of orthoacyl amine or para-acyl amine. So overall reaction overall reaction of photophrase reagent can be represented as follows. This is the when we have aryl ester or aryl amides of structure like this, where X is equal to oxygen. X could be oxygen or nitrogen. Under photolytic condition, leads undergo photophrase rearrangement. This name has been given on the basis of the observation of which was first observed by this gentleman, and then which under photolytic condition involves alpha bond cleavage, giving rise to acyl radical. When this cleaves, gives C double bond O R radical plus this phenoxy radical if X is equal to O, or a amine radical. And then this rearranges through the attack of the phenoxy radical from the benzene ring at ortho position or a para position to give this product. The overall mechanism for the formation of these products from this starting material under photolytic condition involving alpha bond cleavage can be represented as follows. So this is the stepwise mechanism. This is starting material under photolytic condition undergoes alpha bond cleavage to give these two diradical species, the acyl radical and this phenoxy radical. And then this X is as mentioned could be oxygen or nitrogen. This is whenever we have a radical in conjugation with double bond, it delocalizes and it can lead it can it lead to the it can delocalize in such a way as X minus can move to this. So we can represent different resonating structure like this: double bond X, radical here, and then this, and then it can further move to the para position as well to give a species like this. Now the acyl radical which is obtained through the alpha bond cleavage can add to acyl radical or from ortho position, or it can add to the para position to the acyl radical. So here it has been shown how the addition takes place from ortho attack or from ortho attack to give this. So this radical moves here, and then attack of the double bond to give this acyl radical to give this intermediate. This loses a hydrogen atom and abstracted by X, which is it could be oxygen or nitrogen, and then it can, so we can call it as you can term it is a shift of hydrogen atom from the from this to get this to obtain the aromaticity of the compound once again. So this goes like this, and then it abstracted by the X to give this ortho aryl phenyl if X is equal to oxygen, or ortho aryl amine if X is equal to NH. So this is the overall mechanism for the formation of this. If the attack takes place from the para position, then we end up with this X radical can move like this and then to this and then to this. So attack of this to the acyl radical, that's why it is written here, the para attack can lead to this intermediate as the and then this undergo further the hydrogen atom transfer minus H dot abstracted by the by X. So it just, we can call it as a hydrogen atom shift, or we call it as aromatization. So aromatization or goes back to the aromaticity is retained back by this and then to give a neutral compound. So this gives this para aryl phenol if X is equal to oxygen, or paraphenylamine if X is equal to NH2 NH. So the overall reaction can be summarized for the photophrise rearrangement as is: when aryl esters or aryl amides under photolytic condition undergo alpha bond cleavage to giving rise to acyl radical or phenoxy radical. The evidence of the involvement of the phenoxy radical, this one, f x is equal to x is equal to O. The evidence for the formation of involvement of this radical as one of the intermediate or cyclohexadienone. The other part of the phenoxy radical and then cyclohexadienone. I mean it goes. So the involvement of these species in the C double bond O. This is the first species, the acyl radical or phenoxy radical. There is not a phenoxy radical and acyl radical. Acyl radical. The evidence of involvement of these two species during the rearrangement of photophrise rearrangement is well established by flash photolysis experiment, and the product. So this is well established that these two species are forming during the rearrangement of this. The product resulting from meta position, that is what we have observed is the C double bond C6H5 X O. So for example, or we call it as X C double bond O R alpha bond cleavage, and then what we get is the product derived from XH and C double bond OR plus ortho derived product as well as para derived product. The product derived from the meta attack has not been obtained, so there is no evidence of formation of meta. I mean the product obtained from meta attack has not been reported in this reaction. So just to summarize, the Fry's rearrangement is the photoreaction of an aryl ester or aryl amide under photolytic condition undergoes alpha bond cleavage to give you acyl radical and a phenoxy radical, and these two once again recombine via the ortho attack or a para attack to give you para ortho acyl phenol or ortho acyl amine, or para acyl phenol or para acyl amine. As far as the Fry's rearrangement is concerned, the Fry's rearrangement has also been reported under acid catalyzed reaction, and so since we are talking about only the photoreaction, so we'll just concentrate to the Fry's rearrangement, which this reaction takes place on the influence of light, giving rise to alpha bond cleavage. The application of this reaction has been well devised to generate the Fry's rearrangement. Application of this rearrangement has been devised to generate a paracyclophanes as a macromolecule system, and the migration to ortho position. And in this one, so a starting material has been designed where the amide is a long chain amide with the CS2 the 11 times. So, and then ortho position, both the ortho positions of this amide is blocked by the presence of a two methyl groups. So under photolytic condition, what we have observed just now, that the amide undergo alpha bond cleavage. There is a possibility of alpha bond cleavage under photolytic condition to give the acyl radical as well as this N radical, and then this rearranges the acyl radical attacks takes place at para position, because ortho position is blocked. Both the ortho positions are blocked due to the presence of two methyl groups. So the acyl radical attacks at para position to give this dihydro derivative, and then this undergo 1,6 shift or aromatization takes place to give a paracyclophane, a macromolecule system. So this is a very good application of this photophrase rearrangement. If we design a system in such a way that we force the reaction to proceed in a one direction, and this is the case where the photophrase rearrangement gives both ortho as well as para substituted product. Since both the ortho positions have been blocked due to the presence of two methyl groups, there is a possibility of formation of only para derived products, and hence this starting material lead to a cyclophanes as one of the most synthetically important product obtained in this rearrangement. So like this, several more reactions have been studied by properly designing of the starting material, forcing the reaction to either proceed either through the ortho attack or para escape to get the desired product. Now after this, we go ahead for the next named reaction, which is known as the Barton reaction, which involves the photochemistry of organic nitrile. When we have a system like this, nitrile derivatives O, N, double bond O. So when we have this as a moiety attached to a organic system, the reaction proceeds by 4 different steps under photolytic condition. So under photolytic condition, this is the organic linkage or a steroidal linkage having a nitrile derivative ONO moiety. So and this under photolytic condition, this involves 4 different steps. First one is the homolytic cleavage of nitrile takes place, the giving rise to oxy radical and NO radical, and then the second step is internal. If there is a possibility of internal hydrogen abstraction by the alkoxy radical, this radical, and then that takes place, and that is the second step. And third step is the radical coupling, and fourth step is the isomerization of nitroso compounds to oxime. So the organic nitriles under photolytic condition involve these 4 different types of reaction, and the overall reaction has been termed as the Barton reaction as observed by this gentleman. This rearrangement can be well understood by taking an example like this. So this is a steroidal system where we have a ONO linkage, and there is a methyl group in the ring junction. There is another methyl group at the ring junction. Under photolytic condition, as mentioned, the first step is the homolytic cleavage of nitrile to give the O dot and NO dot. So this is the homolytic fragmentation, radical fragmentation giving rise to alkoxy radical and as well as nitrosyl radical. And then this is the first step is the homolysis of the nitrile bond, and second step is the intramolecular hydrogen abstraction by this NO radical. So this abstracted hydrogen atom from this ring methyl group present at the ring junction to give you CH2 radical. So CH2 radical is formed by the abstraction of an hydrogen, and of course this phenoxy radical once again abstracting hydrogen atom from the solvent to give a OH as well. So this CH2 radical can once again undergo radical coupling with the nitrosyl radical which is formed in the first system through homolytic cleavage. So NO radical coupled with the CH2 radical to give a CH2NO, that is the formed by the radical coupling so of this with this to give this. And then this CH2NO is a oxime. This will what we call it as a nitroso compound. So CH2NO, CH2N double bond O. So this CH2NO is a nitroso. Nitroso can undergo isomerization to oxime. So this gets isomerization to this product. So this is the overall rearrangement of Barton reaction where the ONO, what we call is a nitrile derivative connected to a steroidal derivative under photolytic condition undergoes first step is a homolytic cleavage of the NO bond, giving rise to alkoxy radical as well as nitrosyl radical, abstraction of an hydrogen atom from the ring junction of methyl group by the NO2 to give a CH2 radical. This CH2 radical can couple with the nitrosyl radical and then to give a nitroso derivative which isomerizes to give a oxime. So this is the overall rearrangement. ONO is going to oxime derivatives. This is a very good rearrangement involving internal first homolytic cleavage followed by the hydrogen abstraction and then the radical coupling and then the isomerization to give a nitroso to oxime derivative. So this rearrangement is known as the Barton rearrangement as observed by this gentleman in the for this rearrangement. So we have just discussed two different name reaction. Today first one is the photophrase rearrangement, is the alpha bond cleavage of aryl ester or aryl amide giving rise to orthoacyl derivative as well as paradiryl derivative, and application of this if ortho position is blocked to give exclusive paradipole. Second is the Barton reaction where the ONO, whenever we have a linkage like ONO connected to the steroidal system, an organic nitrile under photolytic condition undergo 4 different steps: homolytic cleavage of nitrile bond to giving rise to O dot and NO radical, generation of NO radical abstract and hydrogen atom from ring junction methyl, to then a radical coupling of CH2 with NO to give a nitroso derivative, and then isomerization to give oxime as a final product. So overall rearrangement is ONO nitrile going to an oxime derivative.